think we made our golf coach dislike golf.
That's really sad. Or coaching golf is really easy. All right. Yeah, it's really just being a chaperone. We're going to do some more graphs of sine and cosine to be continued. Graphs, sine, bless you, and cosine. Okay. So you feel pretty confident in your graphing skills. You only asked me one question, which was nice. But I'm going to throw out a different one to you. We're going to do one that has a shift, which we did, yesterday. But this one, you have to do something before you can actually graph the whole thing. I'll show you. Okay, suppose you have y equals 4. What do you like better, sine or cosine?
Cosine.
You do? Oh, I like sine better. All right, we'll go cosine. 4 cosine of 2x minus pi. All right, and let's say that we have to simply just graph it, okay? So, yes, you are. Okay, so what you need to do is you need to figure out the amplitude, the period, and the shift on this one. And what you have to do first is, right now you can't tell what the shift is. People will look at that and they'll say it's shifting pi to the right. And those people are wrong, okay? Because 2x is shifting pi to the right, but x isn't shifting pi to the right.
So you just say it's shifting. Oh, just kidding.
So what you need to do, is you need to divide the 2 out. You were saying it.
Wow.
So you get x minus pi over 2, like that. Okay, and I know that looks kind of weird, but that's going to help you. Oh, it looks great. Oh, good. That's going to help you with your shifting, okay? So the amplitude is 4. The period, now the period won't change. If you leave that 2 next to the x or you factor it out, it's still a 2 there, okay? So that didn't change. So the period is 2 pi over b, which is 2. So the period is just pi. And our shift is a horizontal shift of pi over 2 to the right. And now we're ready to graph, okay? So that's kind of the extra thing that I added today. And there's one more little extra thing that we're going to talk about too. All right, so the period is pi. So we'll go 1, 2, 3, 4. Period's pi, and this is pi over 2.
Why are you drawing the other half of the graph?
What?
Why do you have the other half of the graph there? Why didn't you just cut it short?
I don't know. It's just a habit.
Okay, so there's not like a reason.
Yeah, actually, I'm going to have to extend this since we're going to the right. Everything's getting shifted that way. All right, and then 4. 1, 2, 3, 4. 1, 2, 3, 4. And so let's go ahead and graph this thing. So cosine, which normally would start at 4 right here on the y-axis, is going to be shifted pi over 2 to the right. So that's my special dot. And from there, I think you can do it, right? Yeah? So the next tick mark, you're at 0. The next one, you're down at -4. We're going to need some more, right? And then the next one, you're here. You could also go backwards. You don't have to go forward. You can go, okay, that's going to be here. My next tick mark would be down here at -4. And so your graph would look like this. Oh, man, I missed that.
Mine doesn't look like that.
No? Are yours still pointy? Okay, you got to round it out. See, these curves are really cool. Like, you don't have to draw this or anything. Yeah. 1, 2, 3, 4. Like, for example, when you draw a sine, just your basic sine wave, it looks like this. You're going to find out in calculus that the area under this little half, it's not a circle. The area under there is exactly 2.
No way.
Yes. It's pretty incredible.
False.
It's true. I promise. It's exactly 2. I'm pretty sure.
Why?
Well, you'll use integrals and stuff, and that's later. Have you done anything in physics like that?
No.
No? Okay. All right. Shh, you're on video. All right, here we go. Now, we're going to talk about something called a sinusoid.
No.
It sounds like a disease of some sort, but it's not.
Sinus disease.
Yes, it's actually much better than that. A sinusoid is just basically a function that can be written as a sine function. Function that can be written with sine. Not cosine, but sine. Can be written in terms of sine. Terms of sine. And your calculator actually has that too. That if you went to, say, for example, stat, calculate, and we've calculated a lot of these, right? We've done linear regression, quadratic, cubic, quartic, natural log, exponential, logistic, and look at the last one. There's a sine regression. It's a sinusoid. It'll put it in terms of sine, your function.
Wow.
Pretty cool, huh? Okay, so you're going to get problems like this. Number 2. These ones you are not graphing, but I'm going to give you some information, and you're going to tell me what the equation is. So I'll tell you that the amplitude is 2. The period is pi over 2. This graph goes through the point 0, 0. Okay, and you need to come up with a sinusoid given this information. We want to find a sinusoid. Such a fun word, isn't it? No. Okay, this one's the easy one out of the 2 we're going to do. It's easy because you know sine already goes through 0, 0. So there's no problem with this one. So if the amplitude is 2, so we have y equals 2 sine, and now the period's changed though. The period was 2 pi, you just write sine of x. But the period's pi over 2. But we know that period is equal to 2 pi over b. And we're trying to find out what b is.
Oh shoot, so it's not 2.
Right. So you can go ahead and plug the period is pi over 2, and we can solve this equation for b if you want to. Or you might already know what it is. It's 4. Yeah, some of you guys can get it really fast, right? Because you know 2 pi over what is going to give me pi over 2? Well, that would be 4. Or you can cross multiply and solve this. You get b times pi equals 4 pi. Divide both sides by pi, so b equals 4. So my equation would be y equals 2 sine of 4x. And that would be it. Because I know that this graph has an amplitude of 2. It would have a period of pi over 2. Because remember, period is 2 pi over b, which is pi over 2. And sine already goes through the point 0, 0, so there's no shifting. Okay? You're not feeling good, are you? Go home. It's okay to miss a day. All right, I'll stop bothering you. Number 3. You just want to get through this class? And then you're going home? You promise? No, come on, go home. Can't. Number 3. Here we go. All right. Should have prayed for you this morning. Let's do a harder one. This is the last one of the day. Okay, and then I'll let you guys work on your stuff. The amplitude is 4. The period is pi. But this time, it's going to go through the point 0, 4. You're right, yeah.
It's okay.
No, I made this one up this morning.
But it's a sinusoid, so you can't use can you use cosine?
You can't use cosine. I was talking to Miss Cowie about that this morning. Yeah, you got to do a shift.
That's so dumb.
But then it wouldn't go through 4, 0, would it?
No, then it would be 4, 0 because 0, 4 would be like, that would be
Right, yeah, I didn't plan this one out very well. Okay, so I'm going to kind of go 1, 2, 3, 4. Yes, ooh, I see you. So you're going to pretend like that's your new y-axis, huh? I see you.
No, I said it before.
You were saying that?
Do a vertical shift, and Brett goes, you can just shift it.
And I listened to it. I'm sorry. Okay, here we go. Y equals, all right. So the amplitude's 4. That's nice. We have to use sine, apparently. Okay. And then for this one, the period is pi now. So what would b equal? 2. Yeah. And if you want to, you can set up an equation to solve, but you don't need to. Just kind of think about it, because the period is 2 pi over b. b would be 2, so that it would be pi. So 2x and then plus 4. Nice. Good job, guys.